This week's episodes were brought to you by the generous support of Eric Sumner. Oh, but it's got to be able to move. No, we'll have to use math. No math. Planes use mesh gliders. Yeah, thanks. Yeah, we'll have to use math because we don't want the plane to have to move and do different things. And although it could follow things. All right. So find ray from mouse position. So if we have our camera dot main dot ray screen point to ray, and then we get input dot mouse position. So okay, the way it's going to work is this. Sorry. Bool is dragging camera equals false. If input dot get mouse button down 0. Left click to drag around? Yeah, I think so. And is dragging camera is equal to false. Well, I guess that would always be the choice, the situation here. Mouse button just went down. Start a drag. Dragging camera equal to true. Else if input dot get mouse button up, mouse button went up, stop drag is dragging camera equal to false. We need to know 3 last mouse position. Oh, well, let's come back to that. So yeah, I need ray, mouse ray is equal to camera dot main dot ray from screen point to ray, and input dot mouse position. So there's going to be a ray that's coming out of the camera. It's got a position and a direction that describes how the mouse is effectively pointing. And we just want to find out what is the point at which the mouse ray intersects y equals 0. So that's fine because we've got from our mouse ray, we've got a current origin and a y, and we can divide that based on mouse ray dot direction dot y. I suppose there should never ever happen, but like if mouse ray direction dot y is greater than or equal to 0, debug dot log error, just for my own purposes, why is mouse pointing up? Because obviously we can never intersect the ground plane at that point, and we just return. I mean, is it actually an error? Probably not, but I'm going to log it anyway just because I want to know what situation it could come up. I mean, we definitely want to bail in that situation, but yeah. 50th time Quill's written his code. No, actually, I think in every single tutorial I've ever done, we've always had some sort of ground plane to just raycast against and find the intersection. It's the lazy way of doing it, because this is actually slower, but yeah. Anywho, this is like the length of the ray. It's not ray length exactly, because length is always 1. But yeah, so if we're at like 10 units above, which is the default position for the camera, and the ray's sort of slanty, and it's going to end up with like, well, the 60 degrees is always going to end up the same thing. So this direction in this case would be something like negative 0.3 or whatever it is. So then we end up with like, okay, we've got 30 units away is where we're going to intersect the ground plane, right? Which means that you guys are going to have to correct my math on this one, I'm sure. So the hit position is going to be equal to our origin plus the direction multiplied by ray length. So that's where we're going to hit. Right? So anyway, we want to store this in last mouse position. And then over here we want to say if is dragging camera. Then we want to do this a second time. There. Stay that there. Then we want to say vector 3 if is equal to last mouse position minus hit pause, and then we say camera dot main dot transform dot translate diff in space dot world. And then make sure to set last position to this. Might have gotten the sign wrong. If you had a rigid body or camera, you can add force to move your camera. It looks cooler. I think it's bad. I don't particularly like that. So there's a couple of different ways to do the camera movement. This is a legit point for discussion, right? There is the version. Let me go and drop you in there. And then grab a brush. Okay. There's the version where you click somewhere, drag your mouse over, and then what this is a direction that's telling the camera every frame to move that much. So you sort of click once, drag it slightly to the side, and your camera just starts moving in this direction. Zoom, 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 until you let go. You can go faster, you can go a little slower, you can do whatever. That's a way to move your camera. I'm not personally a fan of that, because it feels too loosey-goosey. I'm much more of a fan of, I want to feel like I'm grabbing the ground here, and I'm dragging the ground over this way. And then the camera's moving like that, but it's instant. So if I like wiggle the mouse back and forth, I'm just moved the camera back and forth instantly. And if I stop my mouse, the camera doesn't move. The camera only moves as I drag. I think normally that's the control mechanic that I like the best, especially for most strategy games. And most strategy games do indeed do that, right? It mostly feels like you're grabbing the map and you're moving it. Which means the camera is actually moving in the inverse of the direction of your grab, is the way that it works out. But it feels like you're grabbing the world. Any chance this works? Probably not. There's no way. Well, I didn't expect it to not work that way. So if I just click and hold, nothing happens. Okay, the Y is not 0 for some reason. And shouldn't it be? Oh, I think it needs an inversion somewhere along the way. There we go. Now we got a Y of 0. That's much better. Okay. We run into this judder situation all the time, and I can't remember. Oh. We need to redo the hit at that point. There you go. That's what I'm looking for. So like, if I just click the peak of the mountain here, and then I move my mouse around. Oh, right, because the distortion is in the corner. It doesn't stay there. But it seems... Because you got to remember, I'm not clicking on the peak of the mountain. I'm clicking at ground level, so it's more like right there-ish. There we go. You see how my mouse is always staying at the bottom of that hex? No matter what I do? That's what I'm looking for right there. Oomph. Feels good. Feels real good. All right, let's get rid of that debug shit. Oh, right here. Whee! Just feels great when you get that drag right. Okay, let's do a zoomy thing here. Which is interesting. How do we actually want the zoom to work? Because that's not an easy question to answer. Because one thing you can do is you can tweak the field of view. Which is actually how a zoom lens works. Right? It's actually how it works, but that's not what you usually mean by zooming when you hit the mouse wheel in the game. What you probably want is the camera to actually get physically closer to the board. Now, I can do that by just changing the Y, but I don't think that's what you want. You sort of... That's a little tricky, because you probably want the camera to zoom wherever you're pointing. That's usually the way you want it to work. You want the camera stretched that far? You want, like, 180, like full-on fisheye mode? But yeah, usually you want, like, if you zoom here, you want the camera to zoom in over there. How do we do that? You want the camera to move closer to that point. Would be that simple? I actually don't know. Let the camera direction... Like, if we just moved the camera closer to there, like literally, you know, move it over while also moving down more, would that visually give the effect we're looking for? I guess there's only one way to find out, right? Yeah, another ray. I mean, yes, that's exactly what you would do. You use a ray. I'm just wondering if translating the camera along that ray is actually the visual effect. Or if it'll just look not quite right. But it would be super easy to do. So, if input dot scroll wheel is an axis, right? Hold on. Pretty sure. Mouse scroll wheel. Yeah, it's an axis. So we just want to make sure that we've got like some actual useful scrolling before we do any processing, because we don't want any like weird drift from, I don't know, random input noise or something like that. Okay, so at this point, someone's trying to scroll. So we have the hit location. already. So we know where the mouse is because we have the hit position. So move camera towards hit pause within a certain limit. By the way, if you're ever trying to do camera.main and it's not like working for you, camera.main is a built-in shortcut to the camera with the tag main camera. If you don't have any camera with the main camera tag, that won't work. There's other things you can do, but that's going to do us for now. Transform.position. So what is this going to do? Well, first of all, I think I've inverted this. Actually, it doesn't feel like it's right at all. Oh. Space.world. Like, something is really weird. Shit, that feels exactly 100% right. That feels exactly 100% right. So that's how they do that. The only thing is the scroll is inverted from the way that I would think. So, like, the lake over here. I'm zooming in towards this lake. I mean, there's other things you can do. One of the things... Okay, so first of all, you need to limit things. Including this way. Although now it really looks like the Hippledop game. That's fantastic. But if you zoom out too far, then you can see, like, oh, that's weird, isn't it? I don't know. And yeah, a lot of these games, when you get in really close, the camera sort of flattens out a little bit. And then as you zoom out, it actually tends to go vertical. Can you drag while zooming? Technically, yeah. Sure, why not? So I guess what we want to say is, I guess we need a magnitude, so we need some sort of pop. Because the deer is actually the distance between us and the target point. We just need to make sure there's a minimum y. That's really it. If camera.main, right here, vector 3 p equals dot position. If p.y is less than 2, it's probably too close, but we'll see. P.y equal to, and if it's greater than, I don't know, 20, set it to that. It'll be a little funny because technically it will still let you sort of zoom when you're too close, but it won't actually get closer. Like, it won't get lower. It might still technically get closer. There you go. So I can keep scrolling in over here, but it actually won't move me any closer. And if I zoom out, same sort of thing. Okay, the zoom out does get a little funny. Like, the zoom in, it's still kind of okay. I guess I could just say something like, if p.y is less than 20, then we get to do the zoom. So we just ignore the zoom action completely after we've zoomed out too much. And then, whoops. And we got to be able to zoom back in again. If dir.y is less than 0 and, there you go, is greater than 0. So you can't zoom out. Oh, but why can't I zoom in? Oh, no, there we go. If it's less than 0 or that's less than 20. Oh. It's because this part is inverted from the way I'm expecting it. Okay, hold on. Let's do that. There. All the signs are being inverted from the way I expect. That's why. Like, why do I keep getting fucked here? Zoom in, zoom out to the max, and then it's still sliding us forward, or sliding us around, which isn't quite right. Oops, this should be an F. If it hits, no. It's fine, because as long as you're trying to zoom in, it's happy. Or if you're less than 20, it's happy. Except that it's still doing it here. I want it to be happy as long as it's under 20, but I'm zooming out, and why is it giving me a negative number? I'm looking at the debug log, and whether I'm scrolling in or out, the Y is negative. What? Of course it is. Wait, how does this even work? How does this even work? Oh, right. Direction isn't the direction that I'm supposed to move in. Direction is just the difference between the camera and the thingy. I kept thinking I'd already multiplied it. I forgot that the scroll amount happens here. I was thinking the scroll amount would be multiplied over here, so it's the absolute direction. There you go. I can't zoom out anymore. I can zoom in all I want. Okay, that took way too long. Clearly I'm getting tired. Can't zoom out anymore because you're at the cap. Maybe, maybe something should still happen if you're trying to zoom out here. I don't think so. And here, I think it's okay to keep, like, zooming in, and that's, like, cool and fun and entertaining. I don't know. I'm somehow okay with it. Maybe it could still try to center. If you're zooming out over a spot, it could still try to center on it. You know what? These are pretty trivial little things. I'll leave it as a to-do. Stop zooming out at a certain distance. To do. Maybe you should still slide around at 20 zoom out, which I guess is what we had before, but you guys can consider it and figure out what feels most comfortable. I'd have to compare about like Civ. Let's change the angle though. So we want our camera angle. So that would be the X component of our camera angle, which would normally be 60. I think it should be 60 most of the time. It's just when you get to the extremes. Extreme! So, change camera angle. If p.y is less than 5. So let's say float low zoom is equal to 5. Float high zoom is equal to 17. So if we're below our low zoom level, then what we're going to do is we're going to set camera.main.transform.rotation to be equal to a quaternion.Euler, where it's the X that we're tuning here, that first one. The rest is going to be using the normal one. Euler.y, and there shouldn't be any around the Z, but we'll just copy that. So we're going to preserve the Y and the Z. It's the X part over here where we're going to do a lerp from 0. Probably 0 is going to be too much. Something like 10 to 60, depending on our height, where so py minus, so we need a min height. Float min height is equal to 2. So py minus min height. So when we're actually at 2, this is going to be a 0. That's good. And it's going to have to be divided by low zoom minus min height. So this is going to be, so at the top, this is going to be worth 5 minus 2 is 3. This is always going to be 3 because it's 5 minus the 2, so that's 3. So 3 divided by 3 is 1. So there we go. So then we have our range. We'll go from 10 to 60. As we go from height 5 down to 2, we'll go from 60 degrees of rotation, which is our normal, down to a 10-degree rotation. So then we want the same thing if you're above high zoom, but it's going to be the inverse, where it's going to go from 60 to like 90 degrees, where it's looking straight down, based on max height studio minus 0.1f. That over there, max height, max height. There, just for whatever. Min height plus 3, max height minus 3. I mean, 3 is still hard-coded, but that's fine. So we want it to hit this. So this is our value of 1. So we want this to be max height minus, whoops. No, hold on. Hey, I want to say a great big thank you to all the June Patreon supporters and these Mic Check supporters. We've got Yukofin, Eric Sumner, Tiburon, Mighty Mix, Pavel Zdanov, Drazion, Michael McClintock, Aaron Toyson, Craig Mortel, The Not So Evil Engineer, Julien Auger-Lafont, Marius Fieldvold, Speedy Savant, Valiant Cake Fiend, Thomas Oberson, Jason Yanity, Stephen Bonnerman, Kale the Quick, and Neil Blakey Milner, and absolutely everyone who watches, shares, favorites, and subscribes to these videos. Thank you so, so much.